I'm here today to talk to you about package management, and in particular about hosting packages. So code you write depends on code that other people write, and you need some way to get it, and boom, all of a sudden you've got a package registry. Unfortunately, or fortunately, there's something wrong with package management. Nearly every language ecosystem builds some form of this. Even tooling ecosystems like Docker build this. The wheel has been thoroughly reinvented. Unfortunately, the most at-hand way to build a package manager, a package registry, also happens to have bad interactions with the way our industry is funded. This talk is something of a sequel to CJ's Economics of Package Management, delivered this year at JSConf EU. She sends her apologies. She couldn't make it due to some bureaucracy issues. My hope is that this talk will be a sequel in the vein of like a James Cameron film, expanding the universe in an approachable way for people who didn't see the original. You can enjoy Terminator 2 without seeing Terminator 1, for example. I might miss the mark a little bit and head down the Silmarillion path, though. If I do, let me know. That's worth talking about. And thank you for that groan. Okay. So let's set the stage. Our story thus far. Over the last 10 years, we, you, me, everyone in this room, and lots of people outside of it, built the largest package ecosystem in the world. We've changed the common practice of our trade dramatically. How we build web applications, run open source projects, how we teach new programmers, and even how we define conference badges. We've done this largely to scratch our own itches, and because it's gratifying to help others scratch their itches. We've done this largely for each other and largely for free. Today, we're able to take advantage of the efforts of hundreds or thousands of programmers just by typing npm install. The dependency graph for a common application these days is both wide and deep. And that graph represents trust. And trust is a trade-off. It means you can leverage the efforts of the community, but any one of those people could choose to harm you. There's a lot of potential power in trust. It helps us achieve things we couldn't do on our own. Generally, this works out. You choose who you directly trust, and most trustworthy actors in the system will behave similarly. Because you have the choice, you are empowered. There is, however, one set of folks who you must trust in a centralized package management system, the folks providing the registry. And there's a lot of power in that implicit trust. CJ used to fret about this power in her time at NPM. She'd put it to us this way: yes, you can trust me now, but what if I turn into a werewolf? Can you protect the registry from an untrustworthy actor inside the system? How does the community verify that they are not, unbeknownst to them, relying on the efforts of werewolves out to harm them? Because we built this commons on top of a privately controlled, centralized registry, we have no recourse but to trust the people with the legal rights to run it, giving them ultimate power over the registry. Many of my former colleagues are among them, and I think they're generally trustworthy, nice people. But change is the only constant. They won't work there forever. The current owners of the registry may not be the future owners. Taking that into account, should this power even exist? Why does this power exist? Why do other communities follow this pattern? Even when the power is placed into the hands of a foundation, it doesn't disappear. PyPI, Ruby Gems, Docker Registry, Cargo, to name a few, are all kind of built this way. There are good people in these ecosystems too, and I don't think they're werewolves. And I also don't think they're interested in becoming werewolves. So why are all these registries patterned on werewolf-enabling architecture? I think you had to look at what constraints make a package registry successful and what the most at-hand ways to achieve those constraints are. A successful registry system must strike a frictionless balance between individuals giving up some control over what they publish and the benefits they receive in exchange. This can be small. As an individual contributor, I don't get final say in my package name. If I wanted to go publish my great new typography subscripting algorithm, Lodash, to the registry would tell me, no dice. Pick another name. There's an important Lodash here already. Maybe more contentious, if I want to remove my code from the registry once I published it, I can't. Once it's there, The pressure of other people relying on my code means that registries are compelled to fix published code in place. If I want to run ads or install a Bitcoin miner in my popular package, the registry is empowered to remove that version, or change my release lines out from under me to prevent that. I don't wholly own my package once I publish it, and that's mostly fine. These are trade-offs that I am, in general, willing to make. Other people making these trade-offs alongside me means that I'm able to trust the code that I'm installing. However, note that the registry has to insert itself through support, tooling, delivery, into each of these trade-offs to enforce them. And only the registry can do so with any measure of authority. Further note that the community doesn't get a say in the rules unless the registry provider chooses to listen. Bad trade-offs are embedded in the good trade-offs. That's not a real website. The most at-hand way to build something like this is to host package metadata at some well-known URL scheme, represented here by registry.biz, and host some fully qualified domain name. Some, like NPM, may even host the code artifacts representing the code carried in a single version of each package themselves. From there, folks will usually layer on an access control system, then expose a mechanism for logging in and publishing new packages. This gives the operators of the registry the control they need to assert authority over the ecosystem they host. However, that control comes at a cost in the long run. It means paying hosting companies for machines and bandwidth, paying people to handle support issues, and paying other people yet to make sure the system scales with use. The bigger the package ecosystem the registry supports, the more it costs to host and support. At the same time, the bigger the package ecosystem is, the more useful it is to everyone working inside of it. This growth is encouraged, but the cost to support that growth keeps rising. So why should we worry? Many ecosystems use the pattern of a centralized registry. Why should we, in the JavaScript and Node community, be especially concerned? As folks who saw Siege's talk will remember, our registry is run by a for-profit, venture capital-funded private company. And as a venture capital-funded company, it is primarily a financial instrument. An investment from the folks with money, with the expectation of extracting more money out of the company when the time comes. When I joined NPM in 2015, I thought that wrapping the ecosystem with a company was a novel, promising way to pay for the rising costs of supporting the ecosystem. 2019 was an eye-opener. This year has been rocky for NPM. NPM lost 18 people across engineering, support, and marketing, often at very high levels. They also settled 4 National Labor Review Board cases. There's been a massive amount of C-level changeover. And finally, GitHub launched their package registry. If there was doubt before, it's gone now. Centralized package management is not a product in and itself, especially one that focuses on a single language ecosystem. It is a line item feature of a centralized product. I started in 2015 and stayed until this year. I stayed as long as I could, and probably longer than I should have. There are still a lot of really great people out there who I want to cheer on from the outside. But I worry that NPM no longer has a lever big enough to live up to their mission, which is to take JavaScript to the stars. That is to say, preserve the JavaScript commons in perpetuity. When I left to start my new gig, I took 3 weeks off in between. It was at this point that Siege and I decided to do something about package management, because we were both deeply concerned. We wrote the first version of our federated registry system, Entropic, together over the course of 5 weeks. CJ announced it at JSConf EU on the 5th of June. I suspect the reason that all these registries, Cargo, PyPI, RubyGems, and NPM, are built the way they're built is because it's easy to design and implement a centralized registry. It's expensive to scale them, but that's not generally a problem a new registry has until it's achieved some degree of success. That is to say, we build easy-to-build registries because we are not guaranteed to encounter the downsides, which come due years later if we are successful. Indeed, the first version of Entropic that we wrote in that first 5 weeks was centralized, and it only took a week to build. On the other hand, decentralized registries are hard to build, but cheap to scale because they spread the cost of operatorship across a larger base. They're hard to build because, as you'll recall, good registry systems are built on enforcing trust-enhancing, friction-reducing trade-offs for their users. And this is easiest to build if there's a global authority. When there's no central authority holding the keys, these trade-offs are harder to enforce. For instance, how do you keep foundational packages from being deleted from a decentralized system? This is our mascot, Static the raccoon. I have stickers, so if you see me, I have stickers for you. In building Entropic, we dissected the trade-offs and came to the following conclusions. So you can see here. First, we need to enforce naming constraints. So 2 distinct low dashes are okay, but in order to disambiguate them, we'll take into account the user that published them, as well as the URL of the Entropic instance to which they were first published. So you can see here, I have a package called varint. I have a user called Chris Dickinson, and an Entropic instance that's not really running right now at registry.neversaw.us. This is a pretty big change from the existing package namespec. It is kind of a mouthful. In order to require Lodash just work, we introduced a new package manifest format that allows aliasing these dependencies. It looks a little bit something like this. Thus, we built a client called DS, or entropy delta, that reads entropic.toml files. This has the handy side effect of avoiding friction with existing packages. You can add a entropic.toml alongside a package.json and publish to both npm and Entropic. In order to enforce that dependencies don't disappear, packages are synced between Entropic instances on use. In the above example, my foo package depends on Siege's bar package, and they're published to different registries. Packages.example.com is also not a real registry. The act of creating this dependency and publishing the package that contains it causes my Entropic instance to mirror the packages from Siege's Entropic instance. Put another way, if I download Lodash from registry.neversaw.us, and it's hosted on packages.example.com, my registry will maintain a copy of that package indefinitely. This solves the problem of packages disappearing, but presents a trust problem. How can I trust that registry.neversaw.us faithfully conveyed the real Lodash to me? Handily, public key cryptography gives us tools to solve this problem. The public key can be of a Entropic instance can be used to verify that a sequence of data was signed by a corresponding private key. We can use this information to say that, yes, this is the package data that was signed by the original receiving registry. Thus, we sign packages. The author signs the package metadata. The server first receiving the publish signs the metadata as well, and every mirror from there signs upon syncing that data. To ensure that spoofing isn't allowed, we intend to build a distributed ledger exposing client verifiable logs of the combination of domains and their public key. The client verifiable log comes to us via Golang, and I'll include a link to their write-up of that at the end of the talk as a QR code. This uses an SSH-style trust on first use, or TOFU system by default. The first time that my Entropic sees another Entropic, A sees B, it consults the ledger to check that B's public key matches the tuple advertised in the ledger. If it's not present, the operator can opt to trust Entropic B and write them into that ledger. This also helps with the problem of disappearing registries. In order to sync these packages between Entropics and between Entropics and clients, we must make them stable. Thus, the packages are stored in content addressable form. If you've used Git, this is kind of the same thing as Git. Each file is stored at a content hash, and the per version metadata is stored as a table of those content hashes. You can see that we have a license file, index, readme, and they all point at SHA-512, SRI, sub-resource integrity form strings as content addresses. If you're not familiar with the concept of content addressability, content addressable data stores work by using a hash function to reduce an input sequence of characters into a shorter sequence of characters with a given probability of collision. One bad hash function might be to take the first character of everyone's name in the room, for example, and you'd end up with lots of people in the C bucket or K or so on and so forth. In a content addressable system, we call the output of that hash function a content address. Data stored at that address must hash to the same value. This has the nice property that if we've already seen a piece of data, we can avoid storing it again. Further, if the data you're inserting contains content hashes, whenever a constituent content address changes, the changes ripple out to the top-level document, which is really handy for us because we want these things to be immutable once they're published for the most part. So if someone were to go flip a content address for a single file, some malicious user, we would be able to see that and say, oh, that version changed. That's a completely different package now. There's only one bit of mutable top-level package information, and it stores a mapping of versions to top-level content hashes. There is a casualty here. This means that we no longer have download counts. The upside is that security could be built by anybody to the side. You can imagine providing a service that advertises known harmful content hashes, which Entropic instances could elect to heed and bail when downloading. Finally, abandoning the value that we've built up on top of the centralized registry is a non-starter. Thus, there's a special legacy account or namespace that mirrors packages from npm on use. Because we're content addressable, we can verify that if you have a copy of legacy lodash from registry.neversaw.us and one from packages.example.com, these package contents are the same, and we only need to store them once. This is what we built, minus the ledger, in that 5-week period. It worked okay. We announced it on the 5th of June, and here we are. So what happened? We pretty quickly drew attention after the talk went out. This happened just as we were ramping up our work at our day jobs. Pretty soon, wham, we hit a wall. The first time I felt the pinch was after pulling an all-nighter, splitting the Entropic service into multiple services. I announced that I would take a vacation from GitHub over the weekend, which gave me space to think about the project for a bit. The initial problem that we really got into was guilt-driven development. That is to say, we wanted to reward people's efforts with quick PR merges. However, this often broke the builds, and the lack of coordination about what was landing pretty quickly spiraled into more work. To address this, we put in place a no working on weekends policy to kind of ratchet down the amount of attention needed on a daily basis. And we created a merge queue, which is a fancy way of saying we created a release engineer role. Also, if Miles sees this, thank you for backporting all those patches in Node. We ground forward this way. We wanted to quickly extricate ourselves from the project, so we brought up public forums and moderators, whom I continue to be thankful for. However, we were starting to feel the pointy end of the economics of open source. That is to say, there were a lot of decisions to be made in the midst of a lot of incoming undirected enthusiasm for the project, and directing these conversations took a toll. A lot of the first few months were spent educating people, incoming people, about decisions we had already made. In retrospect, better documentation would have been worth its weight in gold. Day jobs were starving the maintainers of attention, so we were kind of focused on keeping the wheels on. One solution would be to add more maintainers, but that would require additional coordination, which was in short supply. I personally struggled with the scope of decisions I needed to weigh in on. I had a clear idea of how I wanted to build things, but I also had a hard time striking the balance between my desire for that level of direction over the code base and letting folks self-direct and build ownership themselves. Eventually, the project ground to a halt around August after I took a week-long vacation and unspooled. Kat started her new job, and Siege stepped into management at day job. I want to pause here for a second. Code is never the challenge. It's just what we as a community do well. We learned some things from this experience, and we're ready to try again. Splitting up the one service into multiple services exposed our first misstep. We didn't really have a concrete deploy target in mind. We had an EC2 box running Nginx and a node process and Upstart, but no real plans around the deploy flow. People really need concrete feedback loops, and developing the service locally did not give people that feedback. We drew a lot of contributors looking to make our entropic.dev website better, as it was, and still is, entirely unstyled. But there wasn't a clear connection between contributing to the main repo and seeing those changes on the website, and thus folks spun their wheels. This kind of loops into communication issues. Siege and I are an effective team. However, we need to work on getting communications out from us. An early example, it was unclear and stressful to newcomers to define where we were blessing certain dependencies over others. From our perspective, we were very laissez-faire about picking packages when they're not mission critical. But when they start to affect the major access patterns of the site, we start to get more involved. However, that attitude needed to be written down and communicated, and we came to that late. We eventually did write it down, but generally, we asked for help at JSConf.eu, but we didn't really know what kind of help we needed yet. I think we have a better handle on that now. We're not building the Entropic registry. We're building the first Entropic registry. That is to say, the really important part is nailing the protocol. The syncing between instances, publishing and syncing between clients and instances, the manifest format for packages, and what is expected of the server on receipt of packages. The protocol is where we need the most help right now, particularly around distributed ledgers. So if you're interested in that, definitely head over to the repo. Again, QR code at the end of the talk. Our ultimate goal is to make it easy and affordable to administer an Entropic registry. This effort will only succeed if we invert the relationship between size of registry ecosystem and cost to support the registry. This means that there might not be a single Entropic codebase to fit all sizes. This was novel to me. Before I had been thinking about multiple instances of an Entropic with one codebase. Now you can kind of think of them as many different implementations of this protocol. Ideally, for small instances, the cost of hosting and traffic should be less than $5 a month. For larger instances suitable for supporting a company, $50 or less in hosting a month should be okay. You could picture small Entropics built out of serverless tech, like Lambdas or Cloudflare workers. Larger, always-on instances might target Kubernetes and hosted Postgres. This creates a razor for focusing attention. Does investing in this discussion change the protocol in a way that gets us closer to that hosting cost goal? This is a razor in the rhetorical sense, a rule of thumb that allows one to avoid unnecessary action. The second most valuable way folks can help is by operating Entropic registries. We're not quite at this point yet, but when we get there, we'll put out a call to interested operators. At that point, we'd be happy to hop on video calls or via Discord or IRC and help folks get these set up. We want to experience the friction of setting these up so that we can eliminate it. Put another way, we think federation is the right way forward for package registries, and we want to align doing the right thing with doing the easy thing. So if you're familiar with the card game Munchkin, this is the bad stuff that happens if we fail. So what happens if this doesn't take off? I mean, it's something of a long shot. Most registries are built the way they're built because success isn't guaranteed. Remember, our commons is in the hands of a financial instrument. If they don't make it big, really big, someone else will buy the rights to our commons. Who knows? That might be Microsoft. I am a happy GitHub user. Today, that might look like a good thing. Tomorrow, we might be back to the days of Gates. Embrace, extend, extinguish. Even if the worst doesn't happen, control over the registry gives a company or foundation immense power over an ecosystem. That company alone gets the keys to ecosystem security, code analysis, rulemaking, rule enforcement, and even in a subtle way, shaping how we write code by selectively messaging what trends appear in that registry. I joined NPM back in the day because I believed in the mission. Take JavaScript to the stars. I don't feel entirely comfortable pinning my hopes on a corporation, even a presently good actor. I've experienced firsthand how quickly a company can change. I'm here because I think this effort is our best shot at disseminating a power that should never have been placed in one company's hands alone. We've changed so much over the last 10 years of Node. I believe in this community. And I think with your help, we can take JavaScript to the stars together. And that's my talk. And the QR code currently goes to an empty repo, but I'm going to go push the repo up with the slides and stuff. So thanks very much.
Thanks for that talk. It's really exciting to see kind of how things have evolved since JSConf.eu, when I first saw that talk. So what do you think where do you see the project going in the very short term over the next like 2-3 months? What do you think some of the big developments there will be?
So I think we're going to focus on getting a second Entropic instance stood up. and then work on the syncing protocol from there. One of the things that we're going to focus on is taking a page from the Node project and running more public weekly meetings via Google Hangouts, and so people can watch and join in. But yeah.
Oh, that's going to be exciting to see. Thank you so much, Chris.
Thanks.